This conference will now be recorded.
Okay. Am I audible now?
Yes, sir. Now you are audible, sir.
Okay. Thank you. One second. It's constant disturbance. And my screen is visible? This one I've
Yes,
shared?
sir.
Okay.
Yes, sir. It is visible, sir.
Any other adjustments or thing that you think I should be doing? Or everything is
No, sir. It's
straightforward?
completely fine, sir.
Yes. Okay, so at what time are we starting? Am I already online? Yet to begin.
Yes, sir. You are already online, sir. But the participants have just switched the session, so it will take some time, sir.
Okay.
And before 5 minutes, we have completed the earlier session, sir.
Okay.
They are joining over here, sir. So we can wait for 2 to 3 minutes, sir.
Oh, great.
Sir, hello. Very good morning to sir.
Good morning, sir. Good
We'll
morning.
be just starting this.
Yes.
I hope, sir, you find this platform suitable and we may use it out.
Yeah. It is. First time I'm using this.
Right, sir. Just waiting for the participants to reach around 50. And I'll be just putting the message in the WhatsApp group also so that the participants may join. Yes, sir.
Yes.
Thank you, sir.
Thank you. Hello, Aditya. Hello, Aditya.
Please, yes, sir, please. He might be just interacting with the participants at the WhatsApp group. Please tell me, sir.
Anyone? Am I audible now? I just changed the setting so that I can reduce the ambient noise. Is this audible? Is
Sir,
it
we
clear?
can listen to you, sir. Yes, absolutely, sir. Yes, sir. Uh, Sir, we may start in 1 minute if it is
Yes.
okay. We are reaching to the level of 44 participants already.
Yes, sir.
Yes. Very good afternoon to all of the participants present over here. Today we have an August present among us. He's an actually the industry people, and being an academician, we usually say that we are not aware about what industry is doing right now. But since like these sessions will bring us out the better of us and the industry people here. So we have among ourselves the Mr. Vijay Santagiri. Please welcome him. He is a founder and CEO of Analogica Software Development Private Limited, uh, which is located at Bangalore. And he has also founded one of the edtech platform, that is certishot.com. Vijay sir obtained his BTech in Electronics and Communication, and then he did Master of Technology in Space Systems Engineering from MIT Manipal. He has already worked in various DRDO divisions, ISRO divisions, Army, Navy, and Air Force over the past 10 years, developing some softwares for C4 ISR, spatial temporal information systems, and data-centric decision-making systems. He has already developed a unique fast feature engineering algorithm for feature extraction of time series data, which is again a patented one. This is again a very important thing that yes, nowadays the industry people are doing the patents, and I must congratulate him for the same. He collaborates with the researchers and academicians across the world to develop new and improved prediction systems. Vijay sir started Certishot in January 2021, which is an edtech platform, as I have mentioned earlier. It keeps on focusing on certifications in emerging areas. He has co-founded UniSync International for the sole purpose of helping students to find their dream universities outside India. Vijay sir is the recipient of President's Awards from Honorable President of India. He currently serves as CEO, data scientist, data product manager, developer, and mentor with Analogica. His company is into data products development, artificial intelligence solutions, AI pipeline integration, cybersecurity, and cyber forensic consultant. So, Vijay sir, it's an honor. It is again like an event where we can listen to you. We can just learn from your side. Your vast experience again dwarfs all of us in the field of AI here, and we cannot wait to initiate the session from your side, sir. All to you, sir. Thank you so much, sir.
Thank you, sir. Thank you very much. Welcome, ladies and gentlemen. I'm really honored to be here and being very active partner as Certishot and SPUP together with Center for Cybersecurity. We've done a lot of work, and it really gives me immense pleasure that I'm here, supporting the cause of cybersecurity and bringing in the AI's perspective of it. And I must say that the whole activity that I took to combine AI and cybersecurity, to learn how AI can be applied to cybersecurity, this whole path itself has been very educative for me on a personal level, because I have just realized that there is so much potential, and the things that are gaps that are there that can be um, filled by the future professionals who can combine both cybersecurity and AI together. So we're going to have a small session on it. Uh, can anyone, if possible, the organization can tell me if the audio and everything, the screen and everything is properly visible?
Yes, sir. Audio, screen, everything is visible to us, sir.
Yes, sir. Great. Thank you.
Thank you so much.
So let's begin, sir. Is the chat enabled here? Okay, we can get some chat going on. All right, so I can ask the question here and if people can just react, right? Yes. Okay, so we'll start with the usual definitions and the importance and stuff, but eventually we're going to go into the depths of it in a different way. So here it goes. With the exponential increase in spread of threats associated with daily diffusion of new malware, it is practically impossible to think of dealing effectively with these threats using only analysis conducted by human operators. So it becomes necessary to introduce algorithms that allows us to automate the introductory phase of analysis known as the triage. What do we do here? We conduct preliminary screening of threats. So for a long time, what do? We analyze how the black hat hacker might abuse the system, and then build systems where it is hard for the same thing to happen. So we are always in a defensive mode. We're always in a hoping that our defense mechanism or our castle that we have built is not breached. That's the mindset, of course, which has been there, and rightly so, because that's how it's evolved. But the modern algorithms, the modern technology of machine learning and AI can give us something better, so that algorithms which you can learn, master, will allow us to automate the introductory phase by helping us to do the preliminary screening of threats to be submitted to the attention of cybersecurity professionals, which will allow us to respond in a timely and effective manner to the ongoing attacks. For example, if we take Security Operations Center, there is a software which is always monitoring the activity or the kind of data that is being, the kinds of data sets that are being exchanged between one node and another cloud node, or the server and the cloud, the server and the client. If we can have an automated system where the software that is being built to do a predictive analytics, if that software or that algorithm is able to detect a threat, that gives you 5 to 10 minutes of space to trigger all the other activities that can mitigate the effect. So that's what we are trying to get at using AI and ML. Machine learning, artificial intelligence, all of that are nothing if you don't have the data. And all of that uses past data, past behaviors around which a model is built, which can classify, detect, and do a lot of other things. So the first challenge here is to be able to collect that kind of data, which is in real world. We cannot fabricate it, and it is not easy. Maybe probably financial data has some static elements. There are certain things which are always true there, but combining AI and cybersecurity, you are actually dealing with one of the most challenging areas, because the hackers are themselves so intelligent in their ability to come up with different ways of abusing the system, that the people who are the white hat professionals who are there to build and secure the systems, they need to be one step ahead. So we need to be able to respond in a dynamic fashion, adapting to the changes in the context related to the presence of unprecedented threats. This small statement here has so many challenges here, right? You have to be dynamic. You have to adapt to the changes. To what changes? The changes in the context of what? Of unprecedented threats. See the number of uncertainties. There are dynamic, adapting, and unprecedented. Means you don't know what kind of threats. So here, the attacker has the upper hand. The surprise element is with the attacker, and the game is all about predicting the possible gateways, possible ways in which the attack can happen. But of course, there is still a broad body of knowledge, a very stable body of knowledge here, because you know all the things that can be attacked. We know that if you have put a 10-gate castle around you, there are only 10 gates from where the attack can happen. We know that. So once we know our system, once we know the kind of data that is allowed in the system, we know that even the person who's going to attack will have to adhere or be in that boundary. So there is a boundary. So half of the domain knowledge required to build the data sets here will depend on the knowledge and the depth of penetration of knowledge of the cybersecurity expert. Because if the person misses any dimension in which a possible attack can happen, we would have trained the model to just be a second class model, right? Anyway, so we'll come to that, how it's going to happen. We'll go into the whole thing. So as that implies that it implies that not only the analysts manage the tools and methods. The analysts so far have been managing the tools and methods of cybersecurity, but now with using AI and ML, they can also correctly interpret and evaluate the results offered by AI and ML algorithms. Because AI and ML algorithm may be just, you can think of it as building an automatic intrusion detection. But if you use the statistical methods of AI and ML algorithms, it gives you better results and insights into the data that was generated in the interaction, using which a better system can be built. So there's a lot of purchase out of thinking in terms of data and in terms of AI and ML when it comes to cybersecurity. So in a statement, a small concluding statement of this particular slide, cybersecurity professionals are called to understand the logic of the algorithms, thus proceeding to the fine-tuning of their learning phases based on the results and objectives to be achieved. You need to know the results and the objectives that needs to be achieved for a small system where you know that this is the kind of threat that we're trying to analyze, and this is what we don't want or expect to happen. So once you have those objectives and results in front of you, we can get a lot of things done. Now let's look at some of the tasks related to the use of AI. Classification, clustering, and predictive analysis. We're going to do all of these three. Classification, this is one of the main tasks in framework of cybersecurity. It is used to properly identify the types of similar attacks, such as different pieces of malware belonging to the same family, same class, having common characteristics and behavior. Even if their signatures are distinct, in terms of, if you want to think about the polymorphic malware, of course, malware is something which evolves. There is a lot of changes that happens to stack because it is like its own software, right? So it mimics something else. It comes into your system thinking, cheating the system by saying it is probably doing something and eventually ends up doing something else. But the changes that are happening in terms of the system, where the stacks, the changes, the memory allocation, all of those patterns which are there, that can be recorded, and we can use it to classify. Even though all are distinct, we can still be able to classify based on their behavior, the exact state changes that are being mapped. And using that, we can classify that this particular malware is of this particular class. And one of the using the same classification examples, we can classify emails as being a spam email or a legit email. We'll do this exercise as a part of this session. So clustering, classification is done, it is supervised. Clustering it belongs to something called unsupervised. We'll understand everything. This is the part, this whole thing, what I'm explaining is a very dry text-based thing, but trust me, not much of this session is going to be text-based. This is just to fit the context, just to talk about the things that are happening and what can be done. Now, clustering is distinguished from classification by ability to automatically identify the classes to which samples belong when information about the classes is not available in advance. Means I told you we can classify here based, even though it is distinct, but for this you need to be able to tell the system that this particular thing belongs to class A. If there are activities like this, it belongs to class B. If there are activities like this, it belongs to class C. We have to teach the system. But what if there is some different kind of class of attacks that are happening? You don't even know what classes they belong to. We use clustering to cluster the data, and automatically it is going to give you that. It will give you a pictorial as well as a tabular data information, where then you can observe and inspect and see that there are certain activities which are isolated. There are other activities isolated in a graph, and you can see now that why were in let's say in terms of time and in terms of memory, why was so much memory filled up in so much less time. See, there's a cluster here. Then here it took some amount of time, but still the memory could not reach a certain value, so there is a different class. You can actually detect or discover some classes over here. So that is clustering, which is unsupervised in nature. Now, predictive analytics, here classification is done. Predictive is in looking into the future. If there is some real-time flow, there is some real-time activity that is constantly happening, and if you've built your own layer of AI, just by looking at the pattern, the big patterns that are coming into the stream, these patterns, of course, I'm just drawing like this, but there's a lot of activity here. What happens to each bit, at what time it happens, so many dimensions, how many state changes happen, so much of information the operating system gives us. Any small change, there is a lot of changes that happen. We need to put all of that as our features. Once you get all of them as a feature, then you can train a system and then be able to predict that the next time some patterns like this happen, we can know what kind of an attack is being cooked and how much time do we have, whether we have 5 minutes more before it ends or 10 minutes more or just 1 minute more. If there is just even 1 minute, automatic something can be triggered and mitigated. Applications, just to give you the whole knowledge, just to summarize in terms of cybersecurity key areas, what can AI help in? Network protection is one. The use of ML allows implementation of highly sophisticated intrusion detection systems, which are used in network perimeter protection area. Now, endpoint protection. Threats such as ransomware can be adequately detected by adopting algorithms that can learn the behaviors that are typical of these types of malware. Okay, they're typical. There are, of course, I told you it is again typical means it belongs to a certain class. So classification, thus overcoming the limitations of traditional antivirus software, because antivirus software is all, if you are associated with programs, what kind of programs do we write? All software programs are written with conditional statements. If do this, else do this. Okay, in AI it's not if else, we talk about what if. We have to answer what if. The traditional antiviruses work on if else. If this happens, consult a database and then check what kind of a class antivirus or what kind of a malware is there, and then probably get updated every day and remove those or quarantine those, or these kind of things. But we don't want this to come into our system. So the what if can help you secure your system before the malicious data enters your system. All right, so next is application security. Some of the most insidious types of attacks on web application include the server-side request forgery attacks. Means there's the server-side requested APIs that are being called. You force those APIs and get access to the data. That is how all the data breaches are happening. Now, SQL injection, you put a small code, again, data retrieval, right? SQL injection is that small piece of SQL code that is put into the system where it is going to query those data like passwords, right? So it's going to query and then it'll send those data to a different site where the attacker can abuse it. Cross-site scripting, distributed denial of services. These are all types of threats that can be adequately countered by using AI/ML. One more aspect is suspect user behavior, like identifying attempts at fraud or compromising applications by malicious user at every moment. They occur in one of the is actually one of the emerging areas of applications of DL. I'll tell you what happened with my own experience. And if you want to try, you can try it. You will actually be surprised. I was just about 4 months ago, my laptop's battery failed, and since I wanted a laptop which was tuned for machine learning and AI, which could use a lot of hardware, a lot of computation and stuff, I had bought a gaming laptop, okay, which is not from here. It's an MSI laptop, so it's a heavy duty charger. It wasn't available easily. And it was locked down. So I did a lot of search for this particular charger type. After a while in the night, while I kept on searching because my work should not stop. So I was very aggressively searching for it. I wanted to just pay off right there and then and get the order done in 2 days. After a while, I started observing that there are particular small JavaScripts and the small websites that are coming up, which are talking or just showing me exactly what I want. I know this is a rare product, but it is automatically showing me exactly what I want. I inspected it and I realized that whatever I'm searching aggressively, somewhere some bot is using that information, building a web page and just showing it to me. Then I suspected it. Then I realized to what extent has this been actually automated already. We are actually much behind these people. So that is when I realized that this is really high time that the cybersecurity professionals go a step ahead and understand data in the context of AI and ML, right? So that's one of the experiences that I had. and that is suspect user behavior. I mean, somebody is out there trying to build something and just push it across so that they can, make use of my situation when I'm searching for something aggressively, and just give me a button and a payment, and I just pay it, and that's it, money is gone. Now, Security Operations Center is one more, a framework for creating auto SOC, like Automated Security Operations Center, to get those crucial minutes before the damage is actually done. To get that is predictive analytics. Now, having said all of this, it only points to one thing: importance of domain knowledge, the what and whys of cybersecurity. And what I'm trying to say is, knowing just AI and ML is not enough. Knowing just the hows of cybersecurity is not enough. You have to know the what and whys of cybersecurity, and then combine AI and ML. If you do this, the first thing you will achieve by this is that you will be able to turn the service logs into data sets. Otherwise, you will not even know which data is important to predict. First, you need to know what are the important features which are actually going to add value to your analysis. Once those data sets or those features in the data set is identified, then the work of AI and ML begins. So AI and ML is the step that comes after you've mastered. You should be able to see the service log. You should be able to have an eye for it. From where I came from machine learning and AI, I came into machine learning and AI from the domain of spatial temporal information system. It's a fancy word, but it's a very strong area where you have data which is related to space and time. So I come from masters in astronomy and space engineering. So it was expected of us to be professional in terms of the physics of satellites, on all the things that are moving in space and time. X, Y, Z, comma, T, that is in space, comma, T in time. Okay, so everything we dealt with was with respect to the spatial temporal data. But even then, when we used to work, it was important for us to understand exactly what kind of data we are dealing with, and feature extraction. First identify, or if you're not able to actually identify, you can do extraction. If you're not able to extract, you can do feature engineering, use simpler data and create much more effective data by using some statistical methods, right? So these are all the things that we used to do without being a data scientist. This was just a natural way of things. Back then, when I dealt with data, I wasn't calling myself a data scientist. It was just proper space systems engineering. But so what I'm trying to say is, data scientist, AI, ML is not some special position or title. Okay, it is a part of everything. If you know the domain properly, and if you know AI and ML properly, you will start looking at cybersecurity data and the patterns. So when I used to work with ISRO and other organizations, there were scientists who could just see the satellite data. They didn't even need the graph. Just see the numbers that are coming in, and they used to know what kind of orbit, how much fuel, just by looking at the stream of data that is coming in. So that's how good these people are with the experience. So what I'm saying is, if you are going to build the next level of AI and ML, next phase of AI and ML, you should have a keen real-time board in front of you where you are seeing the interaction with the data stream that is coming in, and have that exercise so you will know what kind of a thing needs to be done where and when. Anyways, let's move to the next phase where we summarize this, what all things can be done. You'll just have the idea, and after that we'll start the understanding AI, because first I wanted to tell you the things that can happen. Then when I move to the actual course where we understand, or I introduce you to the AI, the techniques and the fundamentals of machine learning and AI, then we can talk in terms of cybersecurity and data and information security stuff. Now, basic machine learning for cybersecurity, what can be done? Detecting. Okay, that's a mistake. Detecting email security threats, malware threat detection, network anomaly detection with AI, securing user authentication, automatic intrusion detection, securing and attacking data with AI, and some specific cases where AI can be applied. Detecting obfuscated JavaScript. We'll come to that. Tracking malware drift. Okay, this itself belongs to a field in machine learning and AI called concept drift in machine learning. Okay, the whole, because malware is not a static entity, it changes its nature. So when you're tracking it, so you will call it as a drift. Now you can have botnet detection. There is a botnet topology that you can detect and classify. What about the biometric authentication? With facial recognition, right? Even that can be obfuscated. User authentication with keystroke recognition. You are trying to do, keying in something. So not just the number, but the way you are typing the gaps between your strokes, right? So that also can be used as a feature in authenticating the user. And even those things can be used by the black hat hacker to predict what could be the possible password or the keys into getting into the system. Detecting DDoS attacks, ad blocking using ML, IoT device type detection using ML. This is a hot topic because IoT in 4.0, industry 4.0 is all about Internet of Things. And of course, this IoT device type detection is again connected to the PUFs, the physical unclonable functions, which are the cryptographic permanent digital information embedded into the system devices, where you use challenge response pairs to actually authenticate if the particular IoT device actually belongs to the class, the family, or the cluster that is under one operational unit, right? And of course, you have the deep fake videos that are coming in. You'll just use somebody else's video and mimic or add some different voices to it, and you'll make it look. It has happened with many politicians. It is going to also, if this continues like this, it's going to get so good that you will not be able to trust anything in future. But of course, there are other AI-based methods to detect even deepfake, right? So there's always the attempt from the adversaries and the attempt from the champions to detect it, right? Anyways, so let's understand first, with all this context, let's understand what machine learning is, right? So just if you can give me a thumbs up, if we can now go to a formal introduction to machine learning in AI. Use your chat box, use your chat box, and just give me a thumbs up or a one, anything possible, so that I know. Thank you, Shifali Singh. Thank you, Abhishek. Thank you, Shanta Lakshmi ji. Thank you. Yes. Thank you, Deepa Lakshmi. Yes. All right. Good. All right. Let's move to. Now, this one is going to be a simple story-based introduction to AI and ML. Now, I'm not even thinking like I'm going to forget that you guys are cybersecurity professionals. Okay. We are just going to understand machine learning and AI. It's up to you whether you want to apply it in cybersecurity or you want to go and apply it in stock market analysis, doesn't matter. Wherever you want to apply it, you can. But the most important thing is to understand the fundamentals of prediction itself. Can something be predicted, first of all? Right? After that, the application area comes up. You have to approach a subject like this. It should be an inspection-based study, because we are not kids in school where we have to answer a 5 marks question and just mug up and finish it. It's not that anymore. So when we go into an inspection-based introduction, so we'll be asking a lot of questions to ourselves and answering them on the way. All right. The first question, what is data? Now, data is an output or a facilitated output or of an observation. There are events everywhere in this universe. Unless you put a sensor over there and tries to sense something, you'll never get a data. Okay, things are happening, natural things happen, artificial things happen. Now here in computer systems, these are all man-made systems, and data gets generated because there is interaction. That is also an event. And outside the solar system, or maybe somewhere in the deep abyss in the earth, there is some volcano happening, and that is an event. But if you put a probe or a sensor there to study temperature, then that is some data that is coming to you, right? Now the data just happens to be expressed in different ways. Here we have our number system. If you have any alien friends of yours outside Earth, they would have a different representation, right? And of course, I'm just kidding, but it's interesting, right? Because they would have, their maths would be different. What you call 1 is 1 could be something else for them. That doesn't matter. 1 can be anything, 2 can be called anything, 3 can be called anything. But look at the beauty. This is unity, oneness. This is nothingness. If there are 2 oneness, it's called 2. If there are 3 oneness, it's called 3. Now this pattern will never change wherever you go in the universe. Whichever intelligent civilization may have gone, or may come after a billion years, this fundamental nature of things will not change. Prime numbers will always be there, because you're expressing a system of mathematics in such disciplined way. Now, once we start understanding data in these terms, that's when you get a complete hold on all the things that are possible. Now, the bad part about this is, if a black hat hacker also thinks like this, that's when the issue starts. I mean, we'll come to that later. That's the reason, that's the reality which we have to face, right? That is possible. Anyway, so that's how we want to be able to approach this subject. So that's data, you understood, right? Whenever you want to observe something in this universe, in the events, you are sensing something, you're collecting something. Just happens that you're collecting in terms of numbers and collecting in terms of words. Now that brings us to the types of data, that is quantitative in nature and qualitative in nature. Data that can be measured with numbers such as duration or speed, it's quantized. Now, what is qualitative? Non-numerical data that is categorical, such as yes or no responses, or eye color, blue eyes, brown eyes. You cannot do anything about it. We cannot do anything about if I would say I'm traveling at the speed of 10 kilometers per hour, somebody else is traveling at a speed of walking at the speed of 15 kilometers per hour, somebody else 20 kilometers per hour, right? Now I can actually order this into ascending or descending. But if I say the same person had blue color eyes, Another person who went with 15 kilometers per hour had red color eyes, and of course red is evil. Brown, and 20 kilometers per hour had green eyes. Okay, so now can I order it? Doesn't make sense. On what basis are you going to order? Right? See, there is clear distinction between data. So yes or no responses, eye color cannot do anything, but still there is some ordinality in qualitative also. We'll come to that. Right? So quantitative done, qualitative done, you've understood it. In quantitative, there is discrete and continuous events. Discrete events and continuous events. Discrete events belong to whole numbers that cannot be broken down. Whole numbers that cannot be broken down, such as number of items. Or I'll make it even simpler. If you are going to ask yourself how many times Dhoni has won the toss in all of his captaincy, let's say you're gonna get some number over here, N1. Virat Kohli, you'll get N2. Can anyone suggest any other captain apart from these two? Okay, so Ganguly, right? Okay, right. Okay, I want one more cricket captains from somebody from the audience who's not Dhoni, Virat Kohli, and Ganguly. Anybody, any international captain. Anyone who can think of something? All right, no issues. Now, if you are going to ask the question, go and search how many times they had won the toss. Do you think we're ever going to end up in a decimal value here? Yes or no? Yes, 1, 0, no. Type in, please. Will we ever see a decimal value here? Can I ever have something like 59.5 times? It doesn't work, because the way in which the system is represented, the way in which the whole expectation is put, it doesn't allow us to have a decimal number. So that is a discrete kind of a value. A continuous kind of a value is how much gas is left in your petrol is left in your vehicle, or what is the exact weight of the pizza that is left over in your fridge. All of this, if you want to really be accurate, you can get accurate about it. You can just approximate. Let's say I have just 1 kg of maybe tomato left in the fridge, or if you really want to be accurate, you can go and measure the accuracy and you can say 1.2 kgs. Now, if you want to be accurate, yes, it allows the decimal system. But here, no matter how much accurate you want to be with tosses, you cannot get to a decimal number. So I hope you're understanding. The classification is not a very conveniently or easy to have classification. These classification are based on the types of events. I hope you understand. This is very important. Half the game in data science is to understand what kind of data you're dealing with. And it is so important. More so when you have real-time analytics that is going to come in. Anyway, in qualitative data, quantitative is done, quantize, quantity, numbers done, qualitative. We got two, nominal and ordinal. Nominal is this: blue color, brown color, green color. You're nominating a certain kind of characteristics here. The same thing can happen with, okay, I can now use red color here just to prove a point. Now, if I'm going to measure how comfortable you are looking at a person, and if I want to say how comfortable you are, comfortable, very comfortable, uncomfortable, okay? If you look at somebody with blue eyes, what do you say? Very comfortable. Blue eyes is nice. If you look at somebody with red eyes, uncomfortable, right? Green eyes, okay, comfortable. Now, can we put this, arrange this in ascending order of certain parameters? Like you can say, okay, comfortable, very comfortable, or uncomfortable, whichever way. You want to start with the severity of emotion, you will just say uncomfortable first, then comfortable, then very comfortable. Now there is an order. So data used to describe the order of values, such as 1 is equal to happy, 2 is equal to neutral, unhappy. These are ordinal data. It belongs to qualitative data, but there is ordinality in it. All of this actually matters, because when you can have the same kind of nomenclature in severity, how severe, how much severe an attack is and stuff, because that kind of classes will be required. And all the AI methods and methodologies are actually tailored or tweaked using the classes eventually which are going to be representing it. Now, under continuous data, okay, this is the basic division at the level of types of data. Under continuous data, there are two distinctive classification that happens. That is the interval and the ratio. The interval data is the numbers with known differences between variables such as time. Means that these interval data actually comes out of the system in which you want to do the analysis. For example, if you want to do some time series analysis, you already know that a particular representation, let's say you certainly put weeks over here, and you simply say 1 2 3 4 1 2 3 4. Now this information automatically tells us that we are doing, okay, if you're going to put 5 here, we are doing 1 2 3 4 5. Automatically it says 7 5 or 35 days of analysis. 35 isn't here, but by looking at the weeks and the numbers over here, you know that per every week has 7 days already set. Numbers with known differences between variables such as time. This is okay. This is a good place to be in when you are already measuring, because I'll tell you, prediction is about getting an algebraic relationship between an independent variable and all the dependent variables. So when you know that the independent variable, which is usually time, always the independent variable is time. Sorry about this. There are some messages, and I'll just okay. So always the independent variable is time, because time is independent. Everything else can be measured as a function of time. And the only time in the history of sciences where this was reversed, just I'm adding this, not a part of thing, but I'm adding it because since I'm so stressing the point that it is always independent, the only time in the history where time was not seen as independent and time was put in the y-axis, can anyone tell me when this time became a dependent variable? From t, it was shifted to y-axis. I'll give you a hint. Very famous scientist did that, and that's why he's called the genius in physics. Who would want to complete this? Anyone? You can unmute and tell me. You can complete this. No one? Yes, absolutely. Absolutely. Yes. Because he is the one who said even time will change based on the curvature of space. Okay, this is the only time when time was observed. That is the whole genius of Einstein, because he saw the world in a different way. It turns out to be true. Anyway, so that's the whole thing. Time, for all purposes, will be the independent variable. For certain things where you're talking about the quantum mechanics and stuff, time changes depending on how fast you move. Well, that is not our headache to resolve, but very interesting to understand. Anyways, so that is interval when you already know the kind of things. A ratio is numbers that have measurable intervals where differences can be determined. You used to do all this arithmetic progression, geometric progression in a harmonic series where you had that Tn predicting the nth term in a series, right? Mathematical functions. So how is this computed? The common differences would be taken and a function would be built around the common differences. And then you would be able to say, okay, this is the pattern, this is the building pattern that is happening. And you'll do so based on ratios. Now, these are so important. Intervals and ratios is the fundamental currency, the fundamental connections that all your machine learning algorithms are trying to build. There are different kinds of machine learning algorithms dealing with same data in different ways, based on different kinds of data there is, right? Deals with different ways. Once you start understanding the differences in the data, that is when you'll understand how machine learning works. Anyway, for that, we're going to go into a small journey, because trust me when I tell you 1.5 hours can achieve nothing. When we are talking, what can somebody introduce AI and cybersecurity together, right? The power or the meaning of given 90 minutes to showcase a subject, according to me, is to create enough curiosity to go and do your own inquiries. Now, I'm building this approach to satisfy that thing, where we create enough curiosity, make you comfortable asking those questions, make you happy seeking those answers, right? That's the whole idea, right? Anyway, so what do we have here? Types of data based on the inherent feature of data we have covered. Next, what kind of data you have? This particular thing that you're looking at here is, you have to understand this as a cybersecurity professional. Let me get this out. It is okay. See, data, you understood the meaning of it. You need to handle it. You need to observe it. You need to build models around the data. The data can be anything. In your case, just keep thinking about data that is coming into your system. Every information that flows into your network, every data that you're downloading, all of that, there is a pattern. Now, there is structure in that data. That is called the structured data. If the data is unstructured, you'll be able to detect it. If it is about geographic data, of course, all this latitude, longitude, and the tiles and all that. Of course, the unstructured, structured geographical data can all be real time in nature, not a problem. Natural language data, which is your Twitter data, analysis data, the things that are coming in terms of actual information of worldly knowledge, right? All that. The time series data, that is where time is the independent variable and everything is moving in terms of time, that is trade stock market analysis. Event data, there are certain events happening already clustered, packaged in terms of event packets. You can call it as event data. Network data, I don't have to explain much to you. Linked data, right? Sometimes a lot of data is linked, means that if you get a certain packet and there is another information which needs to be here. And if you get only these two, there is no meaning to it. There is a link. If you get this only, then only the whole data makes sense, right? So there will be certain end corrections which are sent to validate whether this particular data has completely been downloaded, or if there is some missing data or something, right? These kind of data, linked data. So this, all of these kind of data you'll be dealing with in your own way, right? So this, with this, let's go into first. Now, before I move to actually telling you about machine learning algorithms, what kind of machine learning algorithms are there and stuff, it's important for us to go into the journey of mathematics. I'm not going to go into a very deep journey of mathematics. I put together a very small step-by-step question-based mathematics, which I call the journey of X. Okay, so of course X stands for a variable, and what all things that a variable undergoes. It can be a number, it can be a decimal number, anything that it represents. X is that representation. So we start here with this journey of data. In what I'm trying to say now is journey of X, the evolution of the number X, right? So we start with this statement, which is written here: brain is a reverse entropy engine. When I say reverse entropy engine, entropy means measure of disorder. Okay, and if there is any instrument or any device in this world which is tuned to reverse disorder, it is the brain. Everything else is not. Your bottle lying next to you is not going to get up and clean or get your table clear. If something falls, glass falls, it's automatically never going to join itself. Things naturally drift, things naturally disintegrate. Even our own bodies naturally disintegrate. But for the given healthy period of time, of the way the brain functions is to put order into the system. Why am I saying this? You'll know in the next slide. Now, this is how the brain is devised, and you will see how naturally this brain evolved from the prehistoric times to the present day, where maths and stuff is all put into perspective, and from where you'll actually start your journey into machine learning and AI. Okay, because you want to teach machines, you have to know a lot of things in a different way. What used to happen? What could have happened in the prehistoric times? Let's say first understand problem of counting. You can see in the picture, there's a small, settlement, a picture of a settlement, a simple life. Nothing, no career, nothing. All you have to do is stay alive in the night, get food in the morning, and for which you will have, let's say, this particular person here has to manage a pair of cattle. That's it. Simple life. Of course, as life becomes more complicated, as ambitions grow, the person will accrue more number of animals. What used to be very simple over here with 0, 1, and 2 being enough, because for them, the prehistoric times, if you read some accounts of great writers, reflecting on the anthropomorphological aspects, how evolution happened, numbers and stuff, things were very simple. Either there is nothing, or there is one of it, or there is two of it, and the next thing you think of is many. 0, 1, 2, many. That's it. That's the whole range of thinking that the prehistoric people had. Of course, as things became complicated, you needed a system to measure all of these things. That's your number system. Okay, so that is how we came to numbers. Now, once we started coming into the number system, mathematicians went into the depths and saw many patterns over there. The beauty of it, as I told you, why mathematicians go into the depth and why it is so beautiful, it's because it's not just a construct we decided to create. It came out of 0 and 1 and a lot of numbers that follow after that. So in that, we feel that there is a natural universe in these numbers, and then it is very interesting to go and check out the different patterns which are there inside. It's very satisfying and a beautiful puzzle when you really want to read the amazing things that can happen in numbers. Ramanujan was one. He used to used to know a lot of things without even proving it. There are beautiful stuff. But of course, our work is not to go into that. We have to appreciate that numbers have its own universe in it, and events are represented using numbers. Fine. As this came about, as parallelly as numbers were being explored, with time, the representation systems evolved. Here, our representation system is a number system. That's an abstract layer, a number system which represents the complexity of the world. But with time, evolution led to higher levels of abstract systems. Now, continuing, the counting numbers evolved as a representation of series. It also gave rise to the idea of geometry. For example, asking a question of what is mine, what is yours? You need to be able to measure something. And you will measure if, say, there is something in terms of a layout over here, you'll have length into breadth, which is, let's say, 10 into 5. So you keep something which is of 5 dimensions 10 times like this. So whatever the number comes in, it represents the value of this space. So a number now gets a meaning. So this meaning that this number projects, meaning that this number projects, is very important. So why am I saying this? Because you will find numbers which projects a meaning even in your data logs. So once you know what numbers are important, you will know what features are important. That's why I'm connecting these dots for you. Now, finding routes, directions, coordinate system. Descartes, René Descartes was a mathematician who gave this beautiful system of coordinates, x, y, and of course after that the z axis. And then if you want to see the whole thing move in time, then you would add an abstraction of t. But this was as simple as if you want to do some location in terms of, let's say, global location, local location on Earth, this is enough. But the things that I'm talking about, the adaptation, the changes, the dynamic nature, these are just silly dimensions. 1, 2, 3, 4 is nothing. The kind of changes that you can observe, I'm not saying you may, it's up to you. How much of a deep analysis can you do about your data, about your system, is up to you. The more you analyze, the more you bring to the table, the more dimensions you have to study. So with that more dimensions that you're going to bring in, the complexity of the system increases. With the complexity, you will have better algorithms to solve it. So that's okay. It can be done. One of the most beautiful things that happened from these number systems over here is somebody asked the question, let the number be x. Okay, that this, if you can just simply sit and think, we have just used, because from the beginning, from our school days, we've been trained to ask this question. But think about the person who first thought about this. It is don't you think it's an amazing feat in thought itself to think of putting a number x and building an algebra around it so that you can find the x later? If you really think of the first set of people who devised this, you'd probably ask for the set of those people and build a temple for them, because you can clearly see what kind of a big breakthrough it is in terms of thought process itself. So that's why I call this the journey, the evolution of X. I don't know who that person was, the first people. Maybe there's a lot of people, but given the chance, in my own personal, even if I had a lot of time locked up in some dungeon somewhere, I'm probably spending 20 years, I don't think I would have ever been able to ask this question. But this is fantastic, right? So this gave rise to algebra. Now, as I told you, as you can see in the graph over here also, the entire effort of building a machine learning model, machine learning system, It's all about getting that relationship between different dimensions I was talking to you about. This dimension can be okay, time is already, let's say, let's put time over here, and let's put the memory allocated in here, and let's say the processing power here, and so many other dimensions that you can think of in terms of system. So many dimensions come up here, right? So these algebraic relationship, how did this parameter processing power change with time? Or was there a relationship between processing power and memory allocated? Because every different attack can have a different behavioral system. See that when you start getting this metrics and the logs, it can be for anything. It can be good event, let's say a sanitized event, or an expected event, or a malicious event, or I don't know, I'm not able to use the right word because you cybersecurity professionals might have different terms. I would say a not so good event, which is suspicious event, right? So this suspicious event, good event, all of them will have the same dimension, but the relationship that it is showing with respect to one another, the changes that are happening, that can be reduced to numbers, right? The changes can be reduced to numbers. The moment you put it in numbers, you can predict. That's what is happening. You have to link it, and your domain knowledge is going to help you link from this service logs to this feature. And the knowledge of ML and AI is going to then help you to extract these numbers. And applying a model in today's world is a child's play, okay? Because all models are already ready-made and built. Your only problem is to understand your own domain well enough to see it as a data science problem. And once you see it as a data science problem, you should know your domain well enough to extract the right kind of features and then get your data set ready. After that, any ML and AI engineer can build the system for you. So I hope I'm able to connect. I drift and I quickly shift between different clusters of thought, but I hope you guys are making the connections and seeing the importance of these connections. Give me a 1 if you're able to follow it. You have to just type 1 in the chat. They can put 0.5 to say, okay, trying to follow. If you're not at all able to follow it and not able to understand the drift of where I'm going, you can just put 0. I'll understand whether I should change my approach with respect to, because first time I'm giving a AI and cybersecurity connection. So let me know. Your feedback will be important. Give me a 1 if you understood so far what I'm trying to connect. Thank you, Deepak Mishra. Thank you, Abhishek. Thank you, Santosh. Okay, 1, thank you, Pankaj. No 0.5, no 0. Okay, I'm so happy. I'm so happy. It really encourages me when you give me the feedback. I feel okay, because we are not sitting facing each other. So excellent. Thank you, Nazim. All right, so that's the algebraic relation that I'm talking about, right? Now, once the algebra is done, I was telling you about how much of a change is happening, how much is very important. That's when calculus came in. How much of X? Calculus gets you the answer for it. It combines geometry and algebra and answers not just whether the number can be X. If at all it is certain X, we can also answer how much of a change happened in time. That is dx by dt. And what is this X? Some variable expressed as a function, expressed as a relationship. So it's a lot of different other variables. Now, if you can, here we are doing it with respect to time. Maybe later you can have change in processing speed with respect to change in memory allocation. Don't be disturbed about, oh, how do we do this? it's all done already. All your system, Python, everything, it gives you ready-made systems. You only have to put the right numbers over here. That's it. It will calculate. You should know just what are the powerful systems out there and why it is there. After that, machines can do all things. Now, once you know how much of X is answered, what if you want to ask, is there an X at all? Forget about let there be a number X. Then how much of X? Next question, is there a number X? Is X existing at all? Is there a threat at all? How much? How do you measure if there is the particular kind of threat existing? Now that is given by probability. The system of probability systems. And in fact, one of the exercises that I had planned to do today is the spam filter that I had. So that completely depends on naive base, the conditional probability. Something happens and something else happens. See, this one is here, right? Probability of event A occurring after a probability of B has occurred is equal to probability of B occurring after A has occurred into probability of A occurring and probability of B occurring. It looks very simple. Equation is very simple. Application, if somebody gives you PA, PB, PB, B bar A na, immediately you'll calculate. But given an event, knowing which one is P of B, which one is P of A, and which one is P B bar A is the problem, right? That is where you have to think. You'll have to evolve in terms of thinking. Now, all of this, having said all of this, there is one important fundamental aspect that you need to master before getting into AI and ML. These are all the things that you are supposed to know, but this is something which requires a second revision for you. Statistics. What I'm trying to say here is statistics. And it is not about the number. We are always thinking, okay, there is all these numbers over here, and we do something with numbers. It's not about numbers, it is the difference in the numbers, which is actual information. We think that, okay, this is data is equal to information. Okay, fine, yes, agreed, this is information. But the real information is not 13 and 17. The real information is here, that between 2 and 3, the difference was 4. This is the information. And between 16 and 10, there are 6. Between 5 and 6, between USA, whatever, salesperson here, between the date, this and this, between the order ID, this and this, the units that were sold, the difference was 6. The amount of difference, sale amount, was so much. Oh, I'm not able to calculate this immediately, but anyway, roughly I think it's about 1,900 whatever dollars or something, right? This is real information. And using these differences, if you can recall all your mean, median, and the standard deviation, variance, estimations, the Z scores, the standard scores, all of this has a reality. There is a reason for all this. It's here, okay. The next slide is here. The number, the mean, standard deviation, range, skewness, kurtosis, coefficient of variation, the P25, P75, okay, the P values, okay, the median and the sum. All of this are aimed at digging deeper into the differences in these numbers. So this whole table, which was here, became this table, and this is the magic table. So a complete analysis, a complete system representation of all the changes in event data that you're generating, it requires you to understand. You already know numbers and stuff, but if you really want to start somewhere, start with linear algebra first, understand calculus. I mean, I'm not saying again go back and solve those problems. No, when you take 2-3 problems, and this time when you solve those calculus and differential equations, try asking what exactly is happening to this variable here. Think like that. Once you get your mind trained and tuned to understand these things, probability, condition, probability, and all of that, once you understand these things, that is when you start understanding how you can use your own log data to get these ML and AI systems going. And statistics, of course, is very important. And I have to tell you here that AI and cybersecurity is a difficult very challenging and a golden ticket actually. Okay, so I can, I'm clearly, I'm thinking that in the coming future, software engineering, machine learning and AI, cybersecurity, all of these three things will combine, because we have to address the issue that if a very smart black hat hacker who just happens to be a great programmer and very good at machine learning and AI, if they come in all together, then they can really, really create havoc in the system, right? Anyway, so this brings us to the next, you know, section where we talk about the types of machine learning. So this is going to be a very small section, of course. So here we're going to be understanding different kinds of machine learning. One is supervised, one is unsupervised, one is reinforcement learning. A supervised learning is as the name suggests, it is supervised, and unsupervised, as the name suggests, is unsupervised. What is supervising and what is unsupervised? So we have to discover that. Now, supervised this is how it works, as you can see in the picture here, how supervised machine learning works. Let's say we are trying to build a model, and we give the model, okay, this is a machine. We are trying to teach the machine that these are all different kinds of cats. Okay, we are also going to give all these images to the machine saying, hey, look at this. This is also different kinds of cats. This is also a different kind of cat because this probably is probably all the cats which you found in India. This probably is all the cat that you found maybe somewhere in other Asian countries. This may be all the cats that are usually found in European countries, like this bobcat, very fierce and ferocious cats there. Anyway, so these are all different kinds of cats. Now, at this point of time, once this whole training phase is over, we test it. Okay. Now, while testing, we give cats. When the cat is given, let's say this is given to it. So the system is now able to identify and say, okay, what you've given is a cat. Again, you send in a data set from this, a different, not this is the European cat, right? This is a non-Indian but an Asian cat. So you send this kind of a cat inside and you will get another classification. When you send a dog's photo, it will do its calculation and it will say not cats. It will not say dog. Okay, it will not say, because we haven't trained that something is a dog here. We've put these are the cats. This is an Indian cat. This is an Asian cat in general. This is an European cat, right? Of course, here it is not going to say I'm just putting those labels here because you're seeing three. But here, even if we just take this problem statement as face value, you're just telling this that these are all the different kinds of cat. Doesn't matter, whenever I give you any cat, you let me know whether it is cat. If it is not, you just say not cat. So what happens here? Cat means 1, not cat means 0. If you wanted it to understand dog also, then you would have to give this dog here and say this is cat, this is dog, right? So then you would have 1 and this as 2, where 1 stands for cat, 2 stands for dog. Then it will say 1, 2, right? So dependency, this is all labeling the data. You have the labels. So when you have the labels and a lot of past data, and you know that a variable 1 and variable 2 and variable 3 all have occurred to get a certain result, r1, r2, r3, these are all the variable 1's state events. So some values, a particular value of variable 1 and a particular value of variable 2 and a particular value of variable 3 gave rise to r1, a result 1, right? If you know all of these data and then you feed all of this data into the machine, so it creates an algebraic relationship between these variables, which means the features, which is the called the feature vector, and this one is called the prediction vector. The algebraic relationship between the feature and the predicted vector is already established based on the past data. If you have the past data, the feature vector, the prediction vector, all of that, if you're going to use to build a model, that is supervised machine learning. So sometimes you only have this one. You don't know what the result is. You just know you're just observing the phenomena. You're understanding the difference. Sometimes you're just observing the phenomena. This happens usually. I'll give you a direct example. It happens in astronomy. You must have seen this fields of antennas that are put just to observe outer space data, right? Outer space is continuously sending us data. We filter it using the different bands, that frequency bands that we have, right? So we'll X-ray, infrared, gamma, how much of severity, how much of changes are happening in each. So all that is used, and then we can use it just to classify and cluster. So unsupervised learning is something like that. For example, here you will have just raw input data. Here there is a raw input data that I have just put together a lot of cubes. One cube is just a green circle, and a lot of other cubes are just a square, blue square, and a red triangle. Here we are not going to label anything. When I say, okay, this is a blue triangle, the red triangle, and a blue circle, a blue square, and a green circle, we'll just say, okay, something in red has 3 sides, something in blue has 4 sides, and something in green has 0 sides. So just the side information what we give. So it itself will see what are the different kinds of data it is and cluster it. It classifies and clusters. We are not giving it any relationship like we gave here. We don't know. It just uses spatial Euclidean distances and it computes this. So again, another example, if you want to say, okay, you have all the star, rectangle, triangle, circle, square, and all of this are given to you. A lot of data containing many stars and many rectangles and stuff. So you can have different colors of stars as well. When the system finishes its unsupervised clustering, you will get all the stars in one cluster. You'll get all different colored circles in one cluster and all different colored triangles in one cluster. So the deciding factor over here, which feature was that, is the number of sides. See, number of sides, regardless of the color. Now it depends. If you want number of sides, comma color, you want this in, so you are not dealing with 2-dimensional. You are dealing with 3-dimensional clustering. Happens. It's okay. Machine can do, and no matter how many dimensions you have, machine will be able to do. But you might be thinking, if I'm not able to imagine it, how is machine able to do it? So that is the answer that linear algebra gives you. We talked about algebra, but then if you really are curious of how this dimensionality reduction is done, go and check out the real applications of linear algebra. Okay, so that is where you will get the answer for how the dimensionality reduction is done. And for learning machine learning and AI, linear algebra is a very important subject. And again, when I say calculus or statistics, we are not interested. Nobody, you will never use any formulas. You don't have to buy hard mug, nothing. You only have to know why each term, what is happening when you apply eigenvector or vectorization, a transformation, all of that which are happening, transposing something, what is happening over there? Unit vector, what is unit vector in linear algebra? All of that, when you understand, then you will get a feel for it. And once you get a feel for it, it is really powerful, because you will feel that you will be the only very few people who know the whole magic of it, and you will enjoy applying it. You feel very powerful when you know something so deep. So that's the difference between supervised and unsupervised machine learning. So kindly guys, give me a 1 if you've followed the meaning between supervised and unsupervised, because whatever the next is, it's far away from application right now. Things that you will be using, if at all, in the next 6 or 1 month, 6 months or 1 year, is only between the supervised and unsupervised. So kindly go ahead and tell me if you understood the difference between supervised and unsupervised. 1 okay, perfect, okay, super. But having said that, I would also want to explain this, but of course there's a lot of things I wanted to explain. But before I go into reinforcement learning, I want to show you something. Okay, why am I not able to? Okay, 3.57, right? Let me see. .57. This is a TED talk by the creator of something called this dog, Spot, it is called. See, it is actually fully automated.
That's Spot Mini. He'll be back in a little while. I love building robots. And my long-term goal is to build robots that can do what people and animals do. And there's 3 things in particular that we're interested in. One is balance and dynamic mobility. The second one is mobile manipulation. And the third one is mobile perception. So dynamic mobility and balance. I'm going to do a demo for you. I'm standing here balancing. I can see you're not very impressed. Okay, how about now? How about now? Those simple capabilities mean that people can go almost anywhere on Earth on any kind of terrain. And
anyway, I'll send you the. I'll share this video with you. But there are something which I want to show you. See how it is moving. It is able to.
And here's a bigger robot that's got such good locomotion using its legs that it can go in deep snow. This is about 10 inches deep, and it doesn't really have any trouble. This is Spot, a new generation of robot, just the slightly older than the one that came out on stage. And we've been asking the question, you've all heard about drone delivery. Can we deliver packages to your houses with drones? Well, what about plain old legged robot delivery? So we've been taking our robot to our employees' homes to see whether we could get in the various access ways. And believe me, in the Boston area, there's every manner of stairway, twists and turns. And so it's real challenge, but we're doing very well, about 70% of the ways. And here's mobile manipulation, where we put an arm on the robot and it's finding its way through the door.
Now I want you guys to see this. See the door which it just opened, how it learned to open the door. See this? See this video now. See what the engineer will do now. See this? What the engineer, see this? See, he's pushing it. And the machine is trying to force itself, and that person is pushing it. See this? The robot is trying to climb the stairs, but the engineer is introducing new anomalies in the system. What is the person trying to do? Whatever the person there is trying to do, that is called reinforcement learning. Now, after you've seen that, am I audible? I just switched off the video. I hope I'm audible. Okay, great.
Yes, sir.
Perfect. Okay, so now let's understand what reinforcement learning, because you understood supervised, unsupervised. This is very different. Okay, this is the next ticket, the next golden ticket in cybersecurity. And if you can achieve this, then it is, because I told you, what happens if a hacker, black hat hacker, learns all the AI and ML and everything, what the havoc that it can create. The answer to that havoc is reinforcement learning. Now there is this, it's difficult, but once we achieve this, that's it. The world can be safe. Now you saw the dog was doing something. Let's understand this here in terms of the dog, what the spot dog was doing. The agent, the action, the environment, the observation, the reward. These are the things in reinforcement learning. That's called Q learning, and a lot of different new areas have come up. But the standard thing here is, the simpler explanation here is, you train a machine, and you ask a machine what this fruit is. The machine says it's a mango. You say wrong, it's an apple. Machine says noted. Next time you ask what is this fruit, machine says it's an apple. So you are reinforcing a response. The pictorial representation of its mathematical interaction would be, there's an agent, there's an action, there's an environment. Now the agent was the dog, the action was opening the door, the environment was the engineer who was trying to introduce newer and newer difficult problems in real time, so that whatever the agent has in the algorithm, agent's algorithm was what? It's in simply put, use the arm to open it. No matter what happens, just open and walk through. Now the algorithm itself is so complicated. It's not per se complicated as in terms of difficulty. It's complicated in terms of not in terms of, it's only complicated in terms of degree, not in terms of class. Okay, because there are too many things, parallel things involved, but just because there are just too many things, it may look complicated, but it is not actually so complicated. Machines can easily handle it. Okay, and even humans can easily understand what is happening. It's very simple. But because it is happening all simultaneously, it might feel complicated. That's the only thing when I say complicated. Now the agent is acting, and whenever there is an environmental thing that comes up, and if the agent is able to actually devise a new strategy to overcome it, see, it is itself coming up with different patterns. If it is able to devise a new strategy to open the door, you reward it. You don't say that this is a strategy. We will just say open the door, do anything. Okay, so it will keep doing many things. Whenever that many out of one of the things which is useless activity, we will punish it. And if it suddenly somehow is able to arrive at a useful way of negotiating the door closing on its own, we reward it. I hope you're understanding. It is learning. It is actually learning by mistakes. You let it make a lot of mistakes, and one of those mistakes just pile up and it becomes a fruitful action. Then when you reward it, when you reward something, you are actually rewarding the entire train of thought, how it arrived at that. You're rewarding the whole train of thought, how it arrived at that particular action. And next time onwards, it will know that this is the train of thought it has to follow. Same thing, how I think one machine called Deep Blue, I think it's a chess engine, same way reinforcement learning, and many beautiful things. Even this one, Spot, of course, is completely reinforced learning, and there are many examples where this has been really put into use. And this reinforcement learning comes as its own field. Okay, reinforcement learning is its own field. It's not supervised, it's not unsupervised. It's a very computationally extensive, using parallel computation, distributed computation, and a lot of threads talking to each other in terms of programming. And so it's a different thing. Now that's reinforcement learning for you. And if I had time, probably in our whenever we have our classes and stuff, we actually give different examples. We build a PC Man. How many of you recognize this? Give me a one if you recognize this game. Do people still recognize this game? The Pac-Man, the PC Man, right? Yes. Yeah. So here, what we used to do, who used to be this? This used to be you. And this used to be the computer, right? And our work was to go and eat up all this, right? And finish the game. Now in reinforcement learning, what we want to replace you with the machine. We are going and winning this game, right? What if we train the machine to finish this? And while training, all four of you here, Abhishek, Radhika, Deepak, and Shakshi. This can be Abhishek, this can be Radhika, this can be Deepak, and this one can be Sakshi. So all of you with your own keyboards, you can be the ones who will attack this. And we can train this machine. Now it is not, we have reversed the role. Earlier you were a single player playing this. Now the controls for these four ghosts is with you, and you are going to do everything possible from all angles to reach out and kill this machine. We have reversed the role. And while building this, people have built. We can set up many rules and rewards and punishments. And eventually, once the whole training is over, it will become super intelligent and it will know how to avoid all of you. It will know automatically where to go, right? That is reinforcement learning. You teach by making it do a lot of mistakes and reward the right stuff, right action it takes. Right. To summarize this session, the construct, the whole idea of building a machine learning model starts with something like this. First is the initial data set. That is the log data. Any observation, any event that you want to build a model out of, this can be a suspect event. It can be a log data that you've collected during an attack. All of that is some kind of data. It can look like a JavaScript. It can look like a lot of lines, HTML code, so many things, but it is data. Okay. You will have to find out in a way to curate it and put that into a tabular form. Once the initial data is stored somewhere in your system, you are going to clean it, curate it, and remove the redundant features over there. Some features are repeating, same phenomena expressed in different words, right? Those are redundant, you remove it. After that, you are going to do a pre-processing of the data set. Given any, let's say, 1 lakh data points of some attack, some event where attack happened. So out of that, 80% you'll use as training set, and 20% you're going to use as you're going to use at the testing set. So the 80% of the data which you are going to separate out of this 1 lakh, which means now it is around 80,000 points, 80,000 lines, or 80,000 different files which contain all these attack logs. On that, you're going to build your model. That model can be support vector machine, a deep learning model, a gradient boost, k nearest neighbors, decision trees. What is this? Reinforcement learning, RF. Okay. And all of that, once the model is done, you will test that model on this other 20% of the data. This is a standard procedure in machine learning and AI. Okay. So you can know it. You just Google 80-20 and you'll understand. But basically, it's simple. In a simple way, it's like this. If your exams you do a lot of study, right, students, and you've given a lot of exams. If in this, when you're being taught a subject, if there are 10 different questions that you're taught, and even in the exam also, if you are going to get 5 questions from the 10 questions which are taught in your everyday class, the same 5 questions have been repeated, same number to number. Let's say you're in nursery or in first standard, and you've been taught addition. So in the classroom, you were taught 12 plus 3 is equal to 15. You were taught 11 plus 2 is equal to 13. You were taught 10 plus 8 is equal to 18, right? This was taught. In the exam, should I ask you to answer 15 plus 4 question mark or 11 plus 2 is equal to question mark? Give me a 1 if this is the right thing I should ask in an exam, or give me a 0 if this is the right thing I should ask in an exam. Which one should I ask, 1 or 0? Which one is the ideal test? 1, right? Now, the same way, this is a big mistake if you do it. That's why I'm telling you, when you're training something, when you build a model on the 80%, don't test your model on the data that you've already built. If you do that, you're actually not testing it. It is going to be biased. Okay, so that is why we separate the 20% out and train it on the other 80%. And once the results are out, you put that model to test. How do you put that model to test? Not by using the data set which is already here, by using the data set which is here. Okay, so this is what I wanted to say about the testing and training. Okay, so there are many aspects to it, but I've come to the end of this session. So Arjun sir, so I'll just wind this up by giving you a small conclusion. I had a lot of other stuff, but anyway, it's okay. The questions that we want to conclude here is, what if a black hat hacker masters AI and hacking both? How insecure can the world become? You may want to get the answers for it. And I wish all of you cybersecurity professionals the best in your venture into AI. And we at Certishore and SPUP together are there to help you with all the knowledge transfer and training that is required for you in your future endeavors. Thank you. I had to explain a bit more, but due to the time constraints, we can probably have another session somewhere in future. Okay, so with that, sir, I'll be ending this session, and over to you, sir, to the organizers.
Thank you so much, Vijay sir, for your such kind of very informative and knowledgeable session, sir. We really appreciate your effort to make the session more informative and interactive, sir. And you have beautifully explained the use of artificial intelligence in the area of cybersecurity, sir. Thank you so much for your cooperation, sir.
Thank you very much. Thank you, everyone. Thanks a lot. It was fun.
Vijay sir, you can stop sharing your screen, sir.
Yes, yes.
We will now end the session, and so we can switch on to the another session.
Just figuring out how to stop sharing screen. Okay.
So there is a leaf written over here, sir.
I have stopped sharing screen now.
Yes, sir. Thank you so much, sir. And,
thank you, sir.
Thank you so much, sir. We will be now closing this meeting, and I request all of you to join with another link. And the session is scheduled to 2 to 4. I request everyone to be over there. The attendance link will be circulated into the WhatsApp group. So it is highly recommended that you fill that link as earliest as possible. And some of the attendees are requesting me that they are traveling and they won't be able to attend the meet after the coming days. So the attendance won't be compromised in any way. So kindly be attentive in the attendance. Thank you so much.
Thank you. हाँ चली जाओ कोई बात नहीं शाम को